Okay, ladies and gentlemen, now that we've talked about points, lines, and planes, then we've talked about some of our angles, we've talked about some of the angle relationships. Once we begin putting some of those pieces together in different ways, now we come across two-dimensional figures. Now remember, we're going to stay within this singular plane. We're not really expanding beyond that at this point. So we just have two-dimensional figures. Now there are a couple things we need to talk about. First of all, we have 1, 2, 3, 4, 5, 6, 7 of these figures. I'm going to have you answer a couple questions about these 7 figures and as to whether they are polygons or not. Remember, we're asking for polygons, yes or no. Now, moving on, we need to talk about what a polygon actually is. A polygon is multi-sided. And to do that, that means 3 or more, because you cannot create a polygon with only 2 bits. Okay, there's nothing to connect. To connect with only 2 pieces, you would have to have a curve, and that violates rule number 2. All sides straight. Okay, and so this would not qualify. This does not qualify because with only 2 pieces, I can't close the side. Now, additionally, they can be convex or concave. Convex meaning that none of the diagonals will cross any of the sides. Concave meaning some diagonals may cross some of the sides. We'll come back to that in just a little bit. So we have all sides straight. 3, we can't have this situation because all sides connect at endpoints. Now, by the way, all sides must connect at endpoints. This is left hanging. This also is a problem because even though this has a side, it only connects at one endpoint, not the other. So that becomes problematic. So multi-sided, all sides straight, all sides connect to endpoints. Now, those are just some basics for polygons. There is technically one rule that's already broken. All sides straight. Depending on how you wish to talk about it, technically that doesn't apply, and there is one exception, and that one exception is a circle. Now, a circle is still a polygon, and we'll talk a little bit later about why that's still a polygon. But in the meantime, let's do a quick review. Which ones are polygons? 1, 2, and that's it. 1 and 2 are 7. 1, 2, and 7 polygons. So that's what you have for polygons. Now, why is this one okay? It is multi-sided, and it has all sides straight. We're going to assume my my drawing is straight drawing. And they connect at each endpoint. Here, same deal. This, not connected. So the idea is, another way to say connect to endpoints is must be a closed figure. Meaning that if I have a horse, don't make fun of my horse. If I have a horse in the pen, if he can get out, it is not a polygon. Okay, so in this case, it cannot cross over either. Now, we talked about concave and high diagonals can cross over in a closed figure, but these are not diagonals, they are sides. And so sides cannot cross. For now, that'll be enough for these polygons. Now, let's talk about convex and concave. This would be convex. This would be concave. Now, first of all, you have the easy way to remember it because this one is kind of pounded and it's caved in. So that's one way to remember it, but that's not really a mathematical definition. So we can't really use that. What we're going to use is diagonals. Now, a diagonal connects 2 non-consecutive points. Remember, consecutive. If we won consecutive state championships, we would win this year and next year right behind. Versus if we won this year and then we won 3 years later, those are not consecutive. In this case, this is a side because it's consecutive. This is a diagonal because they are non-consecutive vertices. So where two sides come together, it's a vertex. Why? Because it makes an angle. So it makes sense that if it makes an angle, you have a vertex. All of these are called sides. And if I connect two non-consecutive vertices, then it is a diagonal. I can draw diagonals from any point in this figure, and it will never leave the figure. It will always stay interior to the figure, because interior, of course, is inside. Versus in a concave figure, I can draw a diagonal. That's very nice, very nice, very nice. And they all stay inside. Very nice, very nice. Wah, 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 wah. It moves outside the figure, and so it is no longer convex, but it is concave. So we have convex, concave, we have requirements for a polygon. Now we also need to talk about another couple things. Let's talk about perimeter. Perimeter. For every polygon ever, except a circle, a perimeter is add all sides. Now, there are special formulas for a square. The perimeter is 4s. For a rectangle, it's 2l plus 2w. Well, those are dumb, because really all you care about is you need to add all the sides. 4, 5, 5, 4, 3, 5. Okay, here we go. We got 9, we got 14, we got 18, we have 21, we have 26. Perimeter equals 26. That's it. It's no more complicated than that. Now, you can do areas, and there's all sorts of area formulas, but in this case, to do the area of this shape would actually be exceedingly difficult. This is actually an end of the year type of problem, just to find the area of a random polygon. Now, we also have, remember this guy, our circle. Now, a circle, of course, has a center, has a radius, and let's call that radius 3. Now, if that center with radius 3, I need the perimeter of a circle. Well, perimeter for a circle equals its circumference. Now, circumference of a circle is going to be 2 pi r, or pi d. Now, r is, of course, the radius. D is, of course, the diameter. And in our case, we have a radius of 3, so r equals 3, or diameter would, of course, be double that. Diameter is going to be 6. So I'm going to say 2 pi 3, which is 6 pi, or 6 times pi, which is 6 pi. In either case, that is your perimeter. Do not give me a decimal unless I specifically tell you so, because pi is an irrational number, and any attempt to do anything with pi besides the pi symbol means it is nothing more than an approximation and estimate. And we're looking for exact values because we're in big boy math class. So make sure everything stays in terms of pi's when you're talking about circles unless otherwise specified. So we have perimeter, and that perimeter could be for any figure. Now you say, well, why is a circle a polygon? Well, because if we take the most simple polygon we have, which is a triangle, and we add one more side, now we have a square. Let's add another side. That's a pentagon. Before long, you start to see that we can add multiple sides, and the more sides that are straight that we add, the more this figure begins to look like a circle. So a circle can be defined two ways. Circle, set of all points equidistant from the center. It could also be a polygon of infinite sides. Because if I could draw a polygon with 100 sides, you would not be able to tell the difference between that and a circle. So, some polygon two-dimensional figure operations, and now we're ready for one of Mr. Moore's favorite things, the polygon family tree.